Hello, my name is Andrei, and I'm here today to talk about Kubernetes running on Oracle Cloud infrastructure. Actually, we're running our open source product called Skipper, which provides ML workflow orchestration and support for microservices. We're running it on Oracle Cloud infrastructure. We found it working quite well, and the price is decent, and I think it's cheaper than running Kubernetes on Oracle Cloud if you would run it on other cloud vendors. So this is why I decided to record this video and show it to you how it looks like. So hopefully it will be useful and you may try it yourself. So let's jump to the screen, to the action. First of all, this is our Skipper ML workflow on GitHub. Its first production release is available. You can go and use it. Just a few words about the product itself. So what we provide is infrastructure that allows a set of microservices to work together and communicate together. We have an engine which implements Python Fast API framework to provide REST endpoints. Then we have a separate workflow container, separate container for logging, and we have a Celery library which allows asynchronous REST requests in execution for longer tasks. Then we have RabbitMQ as a central container for communication, and all the specific logic related to the RabbitMQ workflow or some generic logic for logger is wrapped into the Python library, Skipper lib. And then we have a set of microservices as a sample services, because you could fork Skipper and create your own services and run on top of Skipper engine your own services. We have sample services for data processing, for ML model training, and for ML model prediction. And all these containers, they run on Docker containers, and then you can take a step further and run also on Kubernetes. Skipper is tested on Kubernetes local and cloud. It works well, so you could run it yourself. Okay, so Oracle. This is the home screen when you log into your Oracle Cloud infrastructure, and then you have a menu list on the left, and then you can create pins for frequently visited menu items, so it's easier to navigate. So let's go to the containers and artifacts, to the Kubernetes clusters. Okay, so this is our Skipper cluster. This cluster runs single node because I'm using it just for testing, but you can easily scale up to multiple nodes if you want. And what is great here is that you can access cluster through the Cloud Shell. So you just press access cluster, copy command to enable kubeconfig on this shell session, and it loads the shell. Okay, we got it, and we execute that command that I copy pasted a second ago to enable access to the Kubernetes environment from this shell. Okay, and we can check. I already actually enabled Skipper on this cluster environment, and we could see which pods are running. So we can see there was no restarts, and we have multiple pods running. And if you are following my videos, in previous videos I described that we are running training service and serving service in different pods because we want to scale serving service differently from training service. Since training is a heavy job, but usually it can be done in the background, and it would not have high user access. And an opposite serving service, which should serve multiple users, and probably you would want to scale it depending on number of users accessing the service. So that's why it should be running in a separate pod. Okay, so cluster is running, and actually in Skipper we have documentation, and there's a separate README file how to run Skipper on Oracle Cloud infrastructure. And basically there's nothing special. You have standard Kubernetes definitions, just few things, mainly to the storage needs to be changed. In these pods, in such pods like RabbitMQ, then training pod and serving pod where we're using storage, you need to change storage class to OCI, and then this means when pod will be created, Oracle Cloud automatically will allocate storage block for that pod. And before you create the cluster, before you create actually your pods on the cluster, you should install Nginx ingress controller. And Skipper is set up in such way that REST endpoints are accessed from the outside through the Nginx ingress controller, and because it allows easily to expose your endpoints through the public port. And for Oracle Cloud infrastructure, you need to install controller the same like you would do on local, but for Oracle Cloud infrastructure, you would install there's a special command that installs controllers specifically for Oracle Cloud. Okay, and the rest of the steps are just to rename storage class, and you run kubectl setup command, and it will create all the pods. And then to find the IP of the load balancer, which is automatically created because you're creating Nginx ingress controller. You can find the IP under load balancers, and this is the public IP of REST endpoint that is installed on this Kubernetes cluster. Okay, and what else? We have when cluster is created, depending on how many instances you selected to be set for the cluster, all those instances are created as VMs automatically, and you can see them under instances menu option. Same for storage. You can check block volumes that were allocated, and in this case, because it's actually RabbitMQ is set up to use block storage, so those two blocks are being created and are available under the block volumes. Okay, and if you would like to delete a cluster, so you would need to delete manually the cluster. Obviously, right, you would go to the clusters menu, and from here you would delete it, but this would not delete load balancer, network configuration, and block volumes. So you would need to go manually delete, for example, to the load balancers. You would go here, delete the load balancer, then you would delete the network configuration that was assigned to the cluster, and finally the instance would be deleted automatically when cluster is deleted. And what else? You would go to the block volumes, and you would delete all the block volumes that were assigned to the cluster. Otherwise, if you would not delete, then you would get you'll be still charged for the load balancer and for the block volumes. Okay, so now let's see, because I have fast API endpoint is exposed through the Nginx ingress controller and is accessible through that public AP. Right, and we have endpoint that allows to run the training, build the model, and another endpoint using that model for the serving pod and executing prediction. So let's open the log for the salary container, which serves asynchronous REST requests, and training task is being executed because it's a long task. It's executed as a synchronous task, and we should see the log printed for the task. And I can go over here, and for the asynchronous request, I would execute training with payload 02, click execute, and then we go to the log. We see that task was submitted, and now in a few seconds we should, we got it already, message the task was completed. This means new model was constructed. And we could actually, when training request was submitted, we got back the task ID from salary ID, which was assigned for that task. And we could go to another endpoint where we could check status for the asynchronous tasks, and we execute with the ID, and we see the task is completed. Right? And then we can go to the synchronous call, which executes prediction based on input data. We execute, then we get back the result from the ML model, which was trained on training data, and based on the training data, it returns these numbers for the input. Okay, so that's how it looks like. And as you can see, actually running Kubernetes on Oracle Cloud is quite simple. And you should be aware only if you would like to delete the cluster, you should manually delete as well load balancer, block volume, and network configuration to make sure that you'll not be charged when cluster is deleted. Otherwise, I was quite happy with the fact that when Nginx Ingress Controller was installed, load balancer was created automatically without any issues, and there was no need to do any additional work. So thanks for watching, and stay tuned. And if you find it useful, please go and give a star to Skipper repository on GitHub. Thanks, and see you next time. Bye.